Hello, explorers of mathematics. In this chapter, we've been dealing with lots of expressions that have to do with exponents. Expressions that have multiplication, expressions that have division, and lots of properties on how to deal with the exponents to help us to simplify these expressions. But have you ever wondered, what do you do with an expression if you have 0 for the exponent? Or what if the exponent is a negative number? How do you deal with that? In this video, we'll look at some ways to help understand how do you simplify an expression if an exponent is 0 or if an exponent is negative. So let's do some math.
Let's start with an expression that's rather simple and one that we know how to deal with. How about if we have the expression 3 to the second power? Well, we know that's equal to 3 times 3 or 9. But what happens if the exponent's a 0? For example, how about 3 to the 0 power? What's that equal to? Is that equal to 0? Something different? How about if I had a negative exponent? How about 3 to negative 2? What's that equal to? Is that a negative number? Let's find out using the properties that we're already familiar with. Suppose I start with an expression that we know how to deal with. How about the quotient of 3 to the fifth all over 3 to the third power? Now we could expand that out. We could calculate what the numerator is equal to, divide it by what the denominator is, or we could use the properties of exponents that we're familiar with. We're dividing with the same base, so therefore we keep that base and we raise it to the difference of the two exponents. So 5 minus 3 results in 3 to the second power, which is equal to 9. But suppose we did the following. How about if we took the reciprocal of this ratio? How about instead of having 3 to the fifth in the numerator, how about if we switched it up and had 3 to the third over 3 to the fifth? That's just the reciprocal of what we have above. Well, we've got a ratio, we've got a quotient, so we have a common base, so we have the base 3, and we raise it to, again, the property doesn't change, the difference of the two exponents. So that would be the exponent in the numerator minus the exponent in the denominator, which gives you 3 raised to the negative 2 power. So what's that equal to? Well, there's only one answer. It has to be the reciprocal of 3 to the second power, because these two ratios are reciprocals of each other. So if they're reciprocals of each other, then their results have to be reciprocals. I want you to think of writing 1/9 as the reciprocal of 3, which is 1/3, raised to the positive 2 power. So 3 to the negative 2 is equal to 1/9, which is equal to 1 over 3 to the second power. We could use the same reasoning to see how we deal with exponents that are equal to 0. Suppose I had 3 to the fifth power all over 3 to the fifth power. Common bases, we're dividing, so we subtract the two exponents. 3 to the 5 minus 5, that's equal to 3 to the 0. Well, what's 3 to the 0 equal to? There's only one answer. Back in the beginning, 3 to the fifth over 3 to the fifth, that's a fraction where the numerator is exactly equal to the denominator, so that's all equal to 1. So therefore 3 to the 0 power has to be equal to 1. There you have it. When you have an exponent of 0, that's equal to 1. When you have an exponent that's negative, you take the reciprocal of the base and you make the exponent positive. One more thing. Suppose we just wrote x to the 0 power is always equal to 1. And suppose we wrote x to the negative n power, any negative exponent, that's equal to the reciprocal of x, 1 over x, raised to the positive n power. That seems to fit what we saw up above, but there's one big problem here. Suppose we did the following. How about if we had 0 to the 0 power? What's that equal to? Well, we might say this. we could say 0 to the third, just to pick a number for the exponent, over 0 to the third is equal to 0 to the 3 minus 3, which is equal to 0 to the 0, which is equal to 1. There's a big problem here. The problem is right back at the first step. We can never divide by 0, and that's what we're doing here. So this line of reasoning doesn't work. 0 to the 0 power is not equal to 1. And for the same reason, suppose we said 0 to some negative power. How about 0 to the negative 1? Well, we might say take the reciprocal of 0, which is 1 over 0, to the positive 1. I'm going to stop right there because we have 0 in the denominator and we can never do that. So what we have here is a true statement for all values of x, except x can never be 0 when you have a power of 0 or you have a negative exponent. All right, we're going to do one quick example here to illustrate this. We'll go through it quickly to illustrate these properties. Suppose we have this expression here. It's kind of complex. It's a ratio. It's a quotient. Let's try to deal with it. First thing I want to do is the numerator isn't going to change because there's nothing I can simplify there. So that's 12 times x to the negative 8 times y to the negative 7. But the denominator I can simplify. This exponent out here, 2, we can distribute that in by multiplying to each of these exponents. So let's do that. First number 2 raised to the second power is 4. So 4 to the second power times x. We multiply 2 times negative 4. That's negative 8. Y. We multiply the exponent 2 times negative 6. So that's negative 12. I'm going to make my work a little simpler. Let me just replace 4 squared with 16 because they're equal to each other. All right, we move down to the next step. We now have lots of things that we can reduce and simplify. So 12 over 16, a common factor for 12 and 16 is the factor of 4. So 4 goes into 12 3 times. 4 goes into 16 4 times. So I've simplified the coefficient. 12 over 16, 3 over 4. What do we do with these common bases x? Same thing we've always done. We have a common base. We're dividing. So we subtract the exponents. X is in the numerator because I'm using my property of dividing with the same base. So I subtract the exponents. So I'll have negative 8 minus negative 8. I subtracted these two exponents. Moving on to the y's, same base, so I use the property of subtracting the exponents. So I have y, it's in the numerator because I'm using the property of subtracting the exponents, negative 7 minus negative 12. Lots of negatives, so use grouping symbols. Let's simplify that. 3 over 4, that's in simplest form. What's x raised to the negative 8 minus negative 8? Well, that's the same as plus negative 8. So we have x to the 0 power. Here we have y. Negative 7 minus negative 12 is the same as plus 12. So negative 7 plus 12 is equal to 5. So we have y to the 5th. And we can carry it one more step. In the numerator, we have 3. X to the 0 is 1 times y to the 5th. In the denominator, we have 4. So this is the simplest form of the expression. Good luck with your homework assignment. Use the examples in the textbook to help you have further understanding. Hopefully this will help you get a start on that. It's time to do some math.